Good day everyone, and welcome to our presentation. We are Burak Combiner, Berkay Umar, Karakas, Farhan Maruf Sofian, and Umar Berkay, here to introduce our groundbreaking research titled SonicDiffusion, Audio-Driven Image Generation and Editing with Pretrained Diffusion Models. We've developed a novel approach, SonicDiffusion, that innovatively fuses audio and visual data for image generation and editing. Stay tuned to discover how we've overcome limitations of existing methods and achieved a more efficient, intriguing audio-visual synthesis. In this slide, we delve into the key highlights of our research. Our primary motivation is to address the limitations of text-reliant image generation techniques. We believe that the integration of audio cues can provide a more natural and cohesive connection with visual content. The problem we're addressing is twofold. First, we aim to efficiently fuse audio and visual data for image generation and editing. This is achieved through our SonicDiffusion model, which leverages audio cues within a diffusion model framework. Second, we strive to maintain the original configuration of the image generation model. This is accomplished by freezing the existing layer weights and adding audio-image cross-attention layers as adapters. These layers serve as a efficient way to fuse the audio and visual modalities, allowing for the incorporation of audio context that aligns with the input sound. This enhances both image generation and editing tasks, demonstrating significant advancements in the field of multimodal image synthesis. In this slide, we delve into the key insights of our work. SonicDiffusion, our proposed model, efficiently fuses audio and visual data, opening up new possibilities in the realm of image synthesis. It maintains the original configuration of the image generation model, ensuring high-quality image generation while adding a novel dimension of audio-driven creativity. Our approach employs a two-stage training process and ablation studies, which contribute significantly to its effective performance. These features make SonicDiffusion a powerful tool for sound-guided image generation and editing, pushing the boundaries of what's possible in multimodal image synthesis. In this slide, we're going to highlight the key contributions of our work. Firstly, we've introduced SonicDiffusion, a novel approach that extends the capabilities of the pre-existing stable diffusion model. This allows us to generate images that are guided by sound, adding a new dimension to image synthesis. Secondly, we've developed audio-image cross-attention layers. These layers are designed to require a minimal set of trainable parameters, making our model efficient and adaptable. Lastly, our model isn't just capable of generating images. It also has the versatility to edit existing images to match auditory inputs, providing a unique way to alter visual content. These key contributions demonstrate the innovative and versatile nature of our SonicDiffusion model. In this slide, we delve into the key highlights of our method. The heart of our approach is the audio projector. This innovative module transforms audio features into what we call inner space tokens. These tokens are then integrated into the image generation model. But how do we do this? We introduce audio-image cross-attention layers. Importantly, we ensure the original configuration of the image generation model remains intact by freezing its layer weights. This means the cross-attention layers act as adapters, allowing us to fuse audio-visual data efficiently. In essence, our method allows us to guide image generation and editing using auditory inputs, a significant step forward in multimodal image synthesis. Begin our frame title key highlights. Begin itemize, item key results, begin itemize, item. Our SonicDiffusion model has shown impressive results in aligning audio and visual elements, significantly advancing multimodal image synthesis. Item, we've conducted extensive ablation studies to understand the impact of different loss functions and training strategies on our model. Notably, we found that a combination of mean squared error and contrastive losses for each audio token yields the best results. Item, the results of these studies have been instrumental in refining our model and ensuring its robustness. We've also discovered that using a weighted summation rather than averaging the loss across all tokens improves the model's performance. End itemize, end frame, Let's delve into the heart of the matter. The authors of this paper are addressing a fascinating and relatively uncharted territory: the integration of audio cues into the process of image generation. If you look at the figure on the screen, you'll see an overview of the SonicDiffusion model, which is the tool they've developed to tackle this challenge. This model is designed to take audio inputs and use them to guide the creation and editing of images. It's a novel approach that opens up a whole new dimension of possibilities in the field of image synthesis. So, let's explore how this works in more detail. Let's delve into the SonicDiffusion model, as depicted in the figure. This model is our solution to the crucial problem of audio-visual integration. Why is this important? Well, audio shares a direct and natural correlation with visual scenes. It provides a rich tapestry of information that text might overlook or find cumbersome to articulate. This makes the integration of audio cues into the image generation process an intriguing frontier. By leveraging these rich audio signals, SonicDiffusion aims to generate images that reflect the vibrancy and dynamism of visual content. This approach not only enhances the realism and creativity of image generation, but also introduces a novel dimension of audio-driven creativity and contextual richness. So, in essence, SonicDiffusion is our key to more immersive and authentic image generation techniques. Let's take a closer look at the SonicDiffusion model, as depicted in this figure. This model is our proposed solution to the limitations of previous text-driven approaches. While these existing methods, such as DAL-E2, latent diffusion models, and Imagine, have achieved impressive results in image realism and creativity, they are not without their shortcomings. Their reliance on text for image conditioning can lead to inconsistencies due to the manual nature of textual descriptions, and their occasional mismatch with visual content. SonicDiffusion, on the other hand, integrates audio cues into the image generation process, offering a more natural and cohesive approach. This innovative model represents a significant step forward in the field of visual content synthesis. On your screen, you can see an overview of our SonicDiffusion model, which is designed to enhance the capabilities of audio-driven image synthesis. Previous efforts in this field have utilized generative adversarial networks and pre-trained text-to-image models. While these methods have been instrumental in laying the groundwork for our research, they have certain limitations. For instance, they often struggle with the depth of audio semantic capture and the quality of the samples they produce. Our SonicDiffusion model aims to address these issues, offering a more robust and efficient solution for audio-driven image synthesis. This model not only maintains the high-quality image generation synonymous with diffusion models, but also introduces a novel dimension of audio-driven creativity and contextual richness with minimal additional training requirements. Let's delve into the proposed solution by the authors. SonicDiffusion. This innovative diffusion model is capable of generating images that are semantically aligned with the audio accompanying them. What sets SonicDiffusion apart is its unique ability to process and translate audio signals into visual representations. This is achieved through the use of audio-image cross-attention layers, which act as a bridge for this modality translation. As you can see in the figure, it provides an overview of the SonicDiffusion model, showcasing its core functionalities. This model not only maintains the high-quality image generation synonymous with diffusion models, but also introduces a novel dimension of audio-driven creativity and contextual richness. It's a leap forward in the field of multi-modal image synthesis, opening up new possibilities for sound-guided image generation and editing. In this slide, we delve into the related works that have shaped the field of visual content synthesis. We've seen remarkable advancements with text-driven approaches like DAL-E2, latent diffusion models, and Imagine. These models have shown us the potential of generating realistic and creative images from text prompts. However, they also highlight a significant limitation: the incongruity between textual descriptions and their visual counterparts. This limitation has led us to explore alternative modalities, such as audio cues, to provide a more natural and cohesive integration with visual content. In the next slides, we will discuss our proposed solution, SonicDiffusion, which leverages these audio cues to generate images that reflect the vibrancy and dynamism of visual content. Moving forward, let's delve into the related works in the field of audio-driven image synthesis. This area of research explores the potential of integrating audio cues into the process of image generation. Unlike text, audio shares a direct and natural correlation with visual scenes. This correlation allows for a more immersive and authentic generation of visual content. Audio provides a rich tapestry of information that text might overlook or find cumbersome to articulate. For instance, the complex soundscape of a bustling city street can convey the atmosphere of the scene, from the brisk energy of a morning commute to the subdued tones of an evening stroll. This depth of context and ambiance is something that text descriptions may struggle to encapsulate fully. In the next slides, we will explore how our approach, sonic diffusion, leverages these rich audio signals to generate images that reflect the vibrancy and dynamism of visual content. In our exploration of existing methods for audio-driven image synthesis, we've identified some key limitations. Previous efforts, such as those based on generative adversarial networks, or GANs, and pre-trained text-to-image models, have certainly paved the way for our research. However, these methods often fall short in terms of the quality of the samples they produce. Additionally, they struggle with capturing the depth of audio semantic information. This means that while they can generate images based on audio input, the resulting images may not fully capture the richness and complexity of the audio cues. In our work, we aim to address these limitations and push the boundaries of what's possible in audio-driven image synthesis. In this slide, we delve deeper into the sonic diffusion model. This model is a significant advancement in the field of audio-driven image synthesis. It goes beyond initial efforts by integrating audio cues within a diffusion model framework. This integration allows sonic diffusion to generate images that are semantically aligned with the accompanying audio. Furthermore, sonic diffusion adapts and extends the capabilities of the stable diffusion model. This extension allows the model to embrace audio information, providing a more nuanced and comprehensive understanding of the scenes. In essence, sonic diffusion is a novel approach that leverages the richness of audio signals to generate vibrant and dynamic visual content. It's a step forward in the quest for more immersive and authentic generation techniques. In this slide, we delve into the unique features of our sonic diffusion model. This model stands out for its ability to process and translate audio signals into visual representations. It's like giving a painter not just a picture, but also the sounds of the scene they're painting. We've also employed what we call audio-image cross-attention layers. These layers act as a bridge, connecting the world of sound with the world of visuals. But we didn't stop there. We made sure that our model maintains the high-quality image generation that diffusion models are known for. So you're not just getting an image that matches the sound, but an image that's detailed and realistic. And finally, we've introduced a new dimension of creativity. By using sound as a guide, our model can create images that are not just visually stunning, but also rich in context and meaning. This is a step towards a more immersive and authentic generation of visual content. On this slide, we delve into the technical details of our proposed research. Sonic diffusion. This innovative approach revolutionizes image generation and editing by utilizing auditory inputs. As you can see in the figure, sonic diffusion is not just a standalone model. It extends the capabilities of the pre-existing stable diffusion model, which is known for its robustness and high-quality image generation. Sonic diffusion takes this a step further by integrating audio cues, thereby adding a new dimension of creativity and contextual richness to the image generation process. This unique combination of audio and visual modalities allows sonic diffusion to generate images that are not only visually stunning, but also semantically align with the accompanying audio. In the next slides, we will delve deeper into how this integration is achieved and the remarkable results it produces. In this slide, we delve into the technical details of our proposed research, sonic diffusion. As you can see in the figure, sonic diffusion is a novel approach that addresses the challenge of integrating audio and visual modalities for image generation. Traditional methods often struggle to efficiently fuse these data types, leading to limitations in the depth of audio semantic capture. Sonic diffusion aims to overcome these limitations by transforming audio features into inner space tokens, which are then integrated into the image generation model. This is achieved through the use of audio-image cross-attention layers, which serve as a parameter, efficient way to fuse the audio and visual modalities. This innovative approach not only maintains the high-quality image generation synonymous with diffusion models, but also introduces a novel dimension of audio-driven creativity and contextual richness. In this slide, we delve into the technical details of our proposed research, SonicDiffusion. The figure you see here provides an overview of the model. A key component of SonicDiffusion is the audio projector. This module is designed to transform features extracted from an audio clip into what we call inner space tokens. These tokens play a crucial role in the image generation process. The audio projector serves as the first principal component of SonicDiffusion, laying the groundwork for the integration of audio and visual modalities in a unique and efficient manner. This innovative approach opens up new possibilities in the field of multimodal image synthesis. On this slide, we delve deeper into the technical aspects of our SonicDiffusion model. The figure you see here provides an overview of the model. One of the key methods we employ is the use of audio-image cross-attention layers. These layers play a crucial role in integrating the inner space tokens, which are derived from audio inputs, into the image generation model. We've ensured that the original configuration of the image generation model remains intact by freezing the existing layer weights. This means that the cross-attention layers act as adapters, efficiently merging the audio and visual data without requiring a significant increase in parameters. In simpler terms, we've created a system that can take sound and use it to guide the creation and editing of images, all while keeping the process efficient and effective. This is a significant step forward in the field of multimodal image synthesis. In this slide, we delve into the technical details of our proposed research, SonicDiffusion. As you can see in the figure, SonicDiffusion is a novel approach that uses auditory inputs to guide image generation and editing. The foundation of this method is the stable diffusion model, which we have adapted and extended to incorporate audio cues. This model allows us to transform features extracted from an audio clip into a series of inner space tokens. These tokens are then integrated into the image generation model through audio-image cross-attention layers. This innovative approach allows us to maintain the high-quality image generation synonymous with diffusion models, while also introducing a new dimension of audio-driven creativity and contextual richness. Stay tuned as we delve deeper into the specifics of this exciting new model. In this slide, we delve deeper into the technical aspects of our SonicDiffusion model. As you can see in the figure, SonicDiffusion is a unique approach that uses auditory inputs to guide image generation and editing. One of the key features of SonicDiffusion is its ability to extend beyond just image generation. It can also be used for sound-guided image editing through a process we call feature injection. This demonstrates the versatility of our model, as it can adapt to different tasks while maintaining high performance. In essence, SonicDiffusion is not just a tool for creating images. It's a comprehensive system that can interpret and translate audio signals into visual representations, opening up new possibilities in the field of multimodal image synthesis. This makes SonicDiffusion a truly innovative approach in the realm of audiovisual research. Moving forward, let's delve into the technical details of our research. As you can see in the figure, our SonicDiffusion model is at the heart of this work. Now, how do we train this model? We employ a two-stage training process. In the first stage, we focus on training the audio projector module. This module is crucial as it transforms features extracted from an audio clip into a series of inner space tokens. In the second stage, we integrate these tokens into the image generation model. This is done through the addition of gated cross-attention layers within the stable diffusion model. This two-stage training process allows us to achieve audio-driven image synthesis effectively. It's a fascinating process, and we'll be diving deeper into each stage in the following slides. Stay tuned. In this slide, we delve deeper into the technical aspects of our SonicDiffusion model. The figure you see here provides an overview of our approach. SonicDiffusion is a novel method for image generation and editing, guided by auditory inputs. It consists of two main components. The first, the audio projector, transforms audio features into inner space tokens. These tokens are then integrated into the image generation model through audio-image cross-attention layers. We've kept the original configuration of the image generation model intact, making the cross-attention layers act as adapters. This allows for a parameter-efficient fusion of audio and visual modalities. Now, let's talk about our evaluation approach. We assess the model's effectiveness in aligning audio and visual elements and its overall performance. We also explore the impact of different loss functions and training strategies through ablation studies. This helps us understand the strengths and weaknesses of our model and guides us in refining it further. In the next slides, we will discuss more about the training pipeline and the results of our model. Stay tuned. In this slide, we delve deeper into the technical aspects of our research. SonicDiffusion, our proposed model, offers a unique and efficient method to merge audio and visual data, paving the way for innovative image generation and editing. One of the key insights of our work is the preservation of the original configuration of the image generation model. This approach ensures that our model is parameter efficient, making it a practical choice for real-world applications. Our model's effectiveness is further enhanced by a two-stage training process and the use of ablation studies. These techniques allow us to fine-tune our model and ensure optimal performance. In essence, SonicDiffusion is a leap forward in the field of multimodal image synthesis, demonstrating the potential of audio cues in creating more dynamic and contextually rich visual content. In our research, we've made significant strides over previous approaches. We've integrated audio cues into a diffusion model framework, a leap beyond initial efforts. This allows us to adapt and extend the capabilities of the stable diffusion model to incorporate audio information. Our approach maintains the high-quality image generation that diffusion models are known for, but we've also introduced a new dimension of creativity and richness, driven by audio, with minimal additional training requirements. This means we can generate images that not only look great, but also reflect the vibrancy and dynamism of the audio input. This is a major step forward in the field of multimodal image synthesis. On this slide, we delve into the technical details of our proposed research. SonicDiffusion, our experimental design is rigorous and comprehensive. We tested our model on 3 diverse datasets to ensure its robustness and versatility. The results were quite promising. Our model not only surpassed existing methods for audio-to-image generation, but also excelled in audio-driven image editing. This was evident in both qualitative and quantitative terms. SonicDiffusion's ability to capture intricate high-frequency details in landscape generation, accurately render human facial features influenced by sound, and precisely map specific sounds to corresponding visual elements is truly remarkable. This demonstrates the potential of our approach to revolutionize the field of multimodal image synthesis. On your left, you'll see a comparison of SonicDiffusion against other audio-driven image editing methods. The superior performance of SonicDiffusion is evident, showcasing high fidelity in aligning generated images with the semantics of the input audio clips. Now, let's delve into the key results. SonicDiffusion not only outperforms existing methods in audio-to-image generation and audio-driven image editing, but it also excels in capturing intricate high-frequency details in landscape generation. This is a significant advancement in the field. Moreover, it accurately renders human facial features influenced by sound, adding a new dimension to image generation. And it doesn't stop there. SonicDiffusion precisely maps specific sounds to corresponding visual elements, reflecting the material properties of depicted objects. This level of detail and precision is what sets SonicDiffusion apart from other models. In essence, SonicDiffusion is a game changer, pushing the boundaries of what's possible in multimodal image synthesis. In this slide, we delve into the conclusions and key takeaways of our research. We've developed SonicDiffusion, a unique and innovative approach for image generation and editing. This approach is guided by sound, opening up new possibilities in the field of multimodal image synthesis. At the heart of SonicDiffusion is the stable diffusion model. Known for its robustness, we've leveraged this model to create a framework that seamlessly integrates audio cues into the image generation process. What sets SonicDiffusion apart is its efficiency. It achieves this integration with minimal training overhead, making it a practical solution for real-world applications. In essence, SonicDiffusion is a significant step forward in the field of sound-guided image generation and editing, demonstrating the potential of audio as a rich and nuanced source of context for visual content synthesis. In this slide, we're going to delve into the key features of our SonicDiffusion model. Firstly, we utilize an audio projector. This unique component transforms the features extracted from an audio clip into what we call inner space tokens. Next, we integrate these tokens into the image generation model. This is achieved through the use of audio-image cross-attention layers, a novel addition to our model. Importantly, we've ensured to maintain the original configuration of the image generation model. We do this by freezing its existing layer weights, which allows us to preserve the model's original functionality while adding our new features. Lastly, our cross-attention layers act as adapters. They provide a parameter-efficient way to fuse audio and visual data, enabling our model to generate images guided by sound. In essence, SonicDiffusion is a blend of innovative techniques that allow us to explore the exciting frontier of sound-guided image generation and editing. In conclusion, our SonicDiffusion model presents a novel approach to image generation and editing, guided by auditory inputs. The methodology is rooted in the stable diffusion model, which provides a robust foundation for our work. We've developed an audio projector that transforms audio features into tokens, which are then integrated into the image generation process. This integration is achieved through the use of audio-image cross-attention layers, which serve as efficient adapters for fusing audio and visual modalities. Furthermore, we've extended our approach to enable sound-guided image editing. This is achieved through feature injection, which allows the characteristics of the audio input to influence the editing process. Our model introduces a new dimension of audio-driven creativity and contextual richness to image generation and editing, with minimal additional training requirements. Thank you. Begin our frame. Frame title at conclusions and remarks. Begin itemize. Item training and evaluation. Begin itemize. Item we've employed a two-stage training process. Initially, we focused on the audio projector module, which transforms audio clips into semantically rich tokens. The second stage was dedicated to integrating gated cross-attention layers within the SonicDiffusion model. Item, our evaluation centered on the model's ability to align audio-visual elements and its overall performance. We've seen promising results, indicating the potential of our approach. Item, we've also conducted ablation studies to understand the impact of different loss functions and training strategies on the model. This has provided valuable insights into optimizing our methodology. End itemize, end a frame, In this slide, we're wrapping up our discussion on the training and evaluation of our SonicDiffusion model. We've used a two-stage training process, first focusing on the audio projector module, and then integrating gated cross-attention layers within the model. Our evaluation has shown promising results in terms of audio-visual alignment and overall performance. Additionally, through ablation studies, we've gained valuable insights into how different loss functions and training strategies affect the model. This knowledge will be instrumental in further refining our approach. Begin our frame. Frame title at a SonicDiffusion methodology. Begin itemize. Item the SonicDiffusion approach. Begin itemize. Item SonicDiffusion is a unique approach that uses auditory inputs to guide image generation and editing. Item, it consists of two main components, the audio projector and the cross-attention layers. The audio projector transforms audio features into tokens, which are then integrated into the image generation model. Item, the original configuration of the image generation model is preserved, making this a highly efficient method. Item, we also extend our approach to sound-guided image editing through feature injection. End itemize, end a frame,